Hi everyone, so in this video I'll show you how to find the gradient of a straight line given 2 points on the line. So let's do a few examples. So we've got a straight line, and then let's say we've got 2 points on the line. So let's say this is 5, 3, and this one is -3, -3. So the first step is to label the points as follows. So you would just write the points down, and then you would label them x1, y1, and then x2, y2. And you can also call this one x2, y2, and this one x1, y1. It doesn't actually matter which way round you label them. It does matter, however, that this one's the x-coordinate and this one's the y-coordinate, because the left coordinate is always the x-coordinate when you're writing coordinates down. And then you would just plug those into what's called the gradient formula. So this is the gradient formula, and it's used to find the gradient of a straight line. We're not going to be finding the equation of a straight line in this video, but this is quite an important step if you wanted to find the equation. So we'll just be covering gradients. Okay, so that would give m equals y2 minus y1, so 3 minus -3, over x2 minus x1, so 5 minus -3. And then you would just simplify that. So that becomes 6 over 8, and that gives 3 over 4. So that would be the gradient of the line. And I'll just mention something about the m as well, by the way. So that's the conventional symbol for gradient. So I'll just write conventional gradient symbol. So whenever you see m in a straight line question, it would always be the gradient. And then the y-intercept is just c. That's the convention for the y-intercept. Okay, let's do a few more examples. Okay, so let's say we wanted to find the gradient of this line this time. So we would expect it to be a negative gradient this time because it's sloping downwards rather than upwards. So we'll just say that we've got 2 points on the line. So let's say this one's 3 minus 5, and this one's -6, 1, for example. So we start by labeling the points. So let's just call this one x1, y1, and this one's x2, y2. And then the gradient formula is y2 minus y1 over x2 minus x1. And you don't get this in the formula sheet, by the way, if you're doing National 5 maths. So you have to memorize this for National 5. So that would be -5 minus 1 over 3 minus -6. So that gives -6 over 9, and that's just -2 over 3. And notice how I didn't leave the minus sign over there, because it's actually a convention to take it outside the fraction. So you wouldn't leave it in the numerator or the denominator. You would always take it outside the whole fraction. That's the convention for writing fractions. Okay, and I'll also show you that even if you labeled this one x2, y2, you would still get the same gradient. So let's just check that quickly. So m equals, so y2 minus y1, that would be 1 minus 5 this time. And then x2 over x1, that would be minus 6 minus 3 this time. And that gives 6 over minus 9. And that simplifies to give minus 2 over 3. So you can see that we got exactly the same gradient, even though we labeled them differently. As long as you keep the numbers together, so x2, y2, it wouldn't be x2, y1, for example. And also you keep the order of the x and y coordinates like this. So this is always the x coordinate, this is the y coordinate. So you can't say y1, x1 or y2, x2, for example. Okay, let's do one more example. Actually, two more examples. So these are interesting examples. They're special cases of the formula, basically. So the first one is going to be a horizontal line, and then we'll do a vertical line as well. So given it's horizontal, the y coordinates would be the same at any point on the line. So let's say we've got this point being 3, 2, for example, and let's say this one's minus 3, 2. And then for this line, the x coordinates would be the same at any point because it crosses one x coordinate, and that stays the same because the line is vertical. So let's say we have the point minus 2, 5, and also minus 2, minus 7, say. Okay, so for the vertical line, so I'll just write V for vertical. We would have, so I'll just call this one x1, y1, and then this one's going to be x2, y2. So it would be y2 minus y1, so minus 7 minus 5, over x2 minus x1, so minus 2 minus minus 2. And you can see what's going to happen now. So that would be minus 12. But in the denominator, we have minus 2 plus 2 because we've got minus minus. And so what happens, that's essentially infinite because when you divide, I mean, it would be undefined technically because you can't divide by 0. So that would have an infinite gradient, and that holds for any vertical line. So usually you would just say undefined. But really it is an infinite gradient because gradient actually increases as you go up, as the slope becomes steeper. So that would technically be an infinite gradient. Okay, so that one's undefined. Let's try finding the horizontal gradient for this line. So we'll just label the points x1, y1, and then x2, y2. So that would be y2 minus y1, so 2 minus 2, over x2 minus x1, so 3 minus minus 3. So that gives 0 over 6, which is just 0. So a horizontal line would always have a 0 gradient. And then a vertical line would always have an undefined gradient. So these results are quite useful to memorize.